Good morning. This is Divyam, and I'll be presenting on applications of regular expressions in network security, which is a topic in theory of computation. We all know that security is very critical in this generation, and regular expression plays a very important role in that. So let's begin. So first of all, why regular expressions matter? So as the cyber threat grows more sophisticated, security systems need intelligent ways to identify malicious patterns instantly. So, regular expression allows us some ways to detect the threats. Like pattern matching is there, where we can detect that if we are getting something malicious or not. I'll explain that better in the next please. Next slides, basically. So, number one is pattern definition. Like in the regular expression, pattern definition is the first thing. What is pattern definition? It is a sequence of characters that define a search pattern for matching text. I'll explain with this example. So basically, think about an email. Okay, email should see this to the power sign is means that it begins with and dollar means ends with. So emails can begin with A to Z, small a to Z, capital A to Z, 0 to 9, dot underscore percentage plus minus. We're assuming that it can begin with this. Then there's a plus sign. Plus sign means that any any amount of characters are possible, but minimum should be one. Okay. At the rate means at the rate should definitely come. Then again same characters, plus sign, then any amount can come. Then slash dot. It means that dot should definitely come, but backslash is there because dot is not like we are not putting dot inside the bracket. That's why. Then some characters can come like like dot com. No? So C can come from here, then O, then M, which minimum is 2, maximum can be anything, and this is the numbering system. So with this regular expression, we can match the text like some specific pattern in the string, like email address. As you can see, IP address also we can match that it's 32 bits, so semicolon comes where, numbers come where, and all everything. And flexible syntax uses special characters to create powerful matching rules efficiently. So what are the anatomy of regular expressions? They are literal characters, which are the exact characters which we have, like in the previous case it was dollar, sorry, at the rate gmail.com. Then there are quantifiers that if there is a star, it means zero or more. Zero or more characters can come. If there is a plus, then means one or more characters can come. And question marks, it means that it either zero or one. Like it's optional. This can come, this cannot come. It's choice. Then character classes. In this square brackets, we define the class. Basically, we will not write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We will not write all. We'll write 0 to 9. Correct. It should match any digit, and A to Z can match any lowercase letters. Then there are special operators like or. Basically, we want either, let's say we want either C to come or A to come. So C, this bar, then A. Anything can come. This is for grouping. Okay, and dot is any character. Let's say C dot T. So the string, our required string can be cat or caught. Okay, or cut. It can be any. Dot means any character can fill that place. Okay. Then we move to how regular expression process text. So we input a string which we have to analyze. Regular regex engine scans for the matches. Okay. The pattern is, if the pattern is matched, they accept it, else they reject it. Okay. Simple, basic, easy. Then we see that how is regular expression used in critical security applications. Number one is threat detection. Basically, regex identifies SQL injection attempts and cross-site scripting patterns in the incoming data stream. Let's say a packet is coming, and inside that packet there are scripts like um, curly angular bracket open script, angular bracket close. Then there is some script is there, then angular bracket open slash script. there is a script inside that. So in we have a regular regex pattern which identifies that a script is coming, and if something like this comes inside a packet, basically we are making an SQL injection attempt. I'll explain that in later slides. Okay, but basically it means that we are prompting our system, like if someone else is sending that packet to us, that packet can technically prompt us to basically it can attack us with that packet, because any instruction can be inside that script which we do not accept. But if we let that packet enter, then we accept it, but we should not. Okay. uh I know it is very difficult, like it is difficult for me to explain because I'm not a teacher exactly, but okay, I'll explain later. Okay? I'll come back to this again. Okay. Then traffic filtering blocks unauthorized access attempts and filters suspicious network packets based on signature patterns. Then let's say a packet is coming from some IP address. Okay, any IP address. So we have regular regex patterns which say that this IP address is malicious. This is not. Accept from this IP and don't accept from this pattern. So that's how it blocks unauthorized attempts. Okay, we know the packet header. We know the header of the packet, how it should look, and if it doesn't look like that, then it rejects it and blocks. Okay, so data validation. Verify input formats conform to expect standard, preventing malformed data from causing security vulnerability. Basically, we validate data. Example, let's say passwords is there. So we say that you can only input a password which should have at least one capital letter, then one small, one number, one special character. That is also done by regular expression only, because let password is comes under security, and password should be strong password. So then there are specific regular regex patterns, regular expression patterns, where we say that this we classify this pattern as strong one and this is a weak one. Okay. So first we go to IDS, which is intrusion detection systems. uh, Pattern-based threat recognition is done by this. So what does IDS does? It monitors the network traffic for known attack signatures using regex patterns. We know the attacking signatures, we already know because they have already attacked us before. Now we are prepared, so we have known regex patterns for that. And if some kind of pattern is matched, it is detected that malicious patterns are detected, the system generates alerts and automatically blocks that suspicious activity. The advantage is directly, obviously, real-time identification of hundreds of known threat patterns. Okay. Now, what how is Regex used in different security systems? If we talk about Snort, Snort basically is a open source IDS using Regex to detect same thing basically. Example, let's say select star from user where one equal one. Let's say this is given inside a script. Okay. So what that script will do? Obviously, one is equal to one everywhere, correct? So all the user data is directly selected, and if there is a prompt that if there is another code after this saying that send it to this person or that person, data leak is very easily possible. And Snort detects these SQL queries. That's what we call SQL injections. Okay, it injects like this. These are the injections basically, some things which we do not want, which we do not want to happen, which basically someone else injects in their packets which reaches us. We do not we do not obviously accept that thing, but as we accept the packet, it automatically gets accepted, and we have been scammed or we have been fished. Okay. Then Suricata, it is modern IDS plus IPS with the pattern matching for advanced threat detection. It is better, faster than Snort because it is multi-threaded. Basically, many multiple threads can work simultaneously and it is faster. That's why. Then ModSecurity, it is a web application firewall which uses Regex to filter HTTP attacks and HTTP traffic and blocks attacks. Okay, so these are some tools which we use from Regex by Regex to match attack patterns and protect network from thousands of known threats. Then firewall packet filtering. Okay, what exactly happens? A packet arrives, we check it using regex. we make a decision whether to allow that packet or to not allow that packet. Then if the packet is malicious packets are rejected and safe packet passes, then traffic control is there. So firewall uses Regex basic rules to filter packets by IP addresses, ports, protocols, and content patterns, blocking malicious traffic before it enters the system. Network. Example, blocking suspicious IP pattern. Some IP address, we know that this IP address is correct, this IP address is not correct. Like this type of, let's say 193.162 point, see it should be 8 bits, 8 bits, 8 bits, 8 bits. Okay, correct? 8888. So we know that this should be the pattern, but then it is not that which we are receiving, so we directly block that IP address. Okay. Email spam detection also works similarly. It detects suspicious sender patterns. Let's say in an email there is saying written click here or urgent or help or like something like this. Some words are there which are usually there in spam emails. Let's say the email address is dot spam, or let's say there's dot gmail.com, right? It is dot gmail.com. Okay. At the rate Paytm, like Payetm. These things regex detects and say that this is a spam email, don't click. Let's say there's a link, there's a URL. Let's phishing attempts with fake URLs. Let's say there's a URL of Paytm or UPI, something like dot SBI dot something is there, that pay on that link. But SBI spelling they have written SBII. It's a wrong one. If there is an Instagram link, but Instagram link they have Instagram E. Okay, some you do not usually directly see those links, but when you click on that link, that is a phishing attempt. That is a wrong link. You click there and fraud is there, and your account is empty. So in these cases, regex helps you. It blocks messages with malicious attachment. Let's say .exe file is there. You know that .exe file usually do not nobody sends an email. So there's a malicious attachment. Dot any extension is there which is not exactly usually sent. .pdf is fine. Doc is fine. But yeah, so it some keywords are there. I've told you like click here or fast, send fast, or something like that. This is how email spam detection is taken care of. Then input validation, first line of defense. Login forms. In login also they ask to put basically same similar thing, password strength. Email format, it shows the email format like .yahoo.com. It knows already previous existing regex file exists, and script tags are there which are told, I have already told about before, I guess. Correct. Stop malicious input filters, special characters, and suspicious patterns that could exploit system vulnerabilities. URL and phishing detection I have already discussed similar. So there are shortened links are also there, like .ig.com. It's Instagram.com, but IG.com. Some links, they have been shortened, so they are fake. Fake domain names I have discussed. .google or .googly. Okay. Match against known, compare URL database of knowing. Okay, same. Block harmful links in real time. So yeah, this is how Regex helps. SQL injection detection. It detects SQL's keyword like select, drop, union, which I've already told, like select star from users where one equal to one. It's always true. So this is an SQL injection. Attackers inject malicious SQL code into input field to steal or manipulate database information. So they can steal. How will they'll send it to someone or something like that. This is how leaks are taken. Like data leak is there. It filters special characters using attacks. Then deep packet inspection (DPI). Basically, what firewall does, it checks the IP header. Okay, IP header, basically it checks a packet header. If it is correct, it allows. Deep packet inspection, what it does, it just not only checks the packet header, it captures the packet, it gets inside the packet, that what content that packet is carrying. Okay. um Basically it scans the packet from contents, and then it says that if there are malicious code patterns inside those packets, then also it blocks that IP address or the sender, whatever. Okay. Log analysis and monitoring. Continuous log scanning. There are logs of what exactly the system is doing. Let's say tunneling is happening. there's a VPN. Okay, a VPN is tunneling to another country. So there are logs coming connected to America, uh, mm, site loading something, and many logs are there. Okay, password matched, password not matched. It sees, let's say in a log, it is coming that user attempted to log in. It's a log one, but failed. Attempted again, 5 times attempted to log in. So it sees that there's a pattern of attempts. Like user always logs at 3 a.m. and logs out at 4 a.m. Something like that. There are logs are there. Okay. Yeah. Logs of user logging into a system. Okay. So it sees that this is some suspicious activity. He is always coming at that time, or he all never remembers his passwords. He always forgets the password. This Instagram or other apps detect this thing and say, okay, this is a fraud. I think this account is handled by some fake person. This is not the correct person to identity. So it continuously scans the logs for searching for suspicious activities and unusual behavior. Yeah, that's what I was talking about. Pattern matching, failed login attempts, unauthorized access system anomalies, same thing. Automatic security alert triggers immediate alerts when dangerous patterns match known attack signatures. Okay. Then advantages and limitations. Advantages are fast pattern matching, flexible and powerful, widely supported. Limitations are complex for large systems because there will be a huge amount of regex patterns which we consider correct and which we do not consider correct. Okay. Then performance overhead, it's going to be very overhead. False positives are possible because it cannot detect unknown attacks easily. Let's say an attack is there which there is nothing in the database that this basically there is an IP address mm, which is a wrong IP address. There is no previous data about that IP address, whether it's correct or not. So in that case, it can let it pass. False positive is possible. Okay. An attack can happen. So yeah, future of Regex is AI plus Regex. Basically, we can ask machines to detect new patterns automatically. Okay, it detects new pattern, it saves them in a database, and Regex can use that so that new attacks are prevented. Smarter detection that we can adapt Regex patterns, learn from threats, and improve over time. Real-time protection, we can basically speed up the Regex pattern recognition with minimum delay. Okay, so Regex remains essential for network security, evolving with AI to protect against tomorrow's threats. So yeah, that's it for the presentation. This was Divyam Madan, and yeah, thank you. Bye bye.